A very warm welcome to Druids across the world to this, our third virtual Druid Summit. My name is Peter Marshall, Technology Evangelist at Imply. Hundreds of people have registered for today's incredible talks from the global Druid community, and following our first presentation by Gian Melino at Imply, it's time to offer my very warm welcome to our second presenter of the summit, Ramon Lastres Guerrero from GameAnalytics. During the presentation, all attendees will be on mute, but that doesn't mean you can't get involved. In the Zoom panel, you will see a Q&A button. Please use that to ask all your questions, and we'll pick those up at the end of the presentation. Any that we don't have time to answer today, I look forward to responding to those in a follow-up blog post. There will be live tweeting throughout, so be sure to follow us on Twitter, and links to the full presentation and to the accompanying slides will be sent following the presentation. Ramon is the Director of Engineering at GameAnalytics, where for many years he's been building a real-time gaming analytics service with Apache Druid. Ramon, I'm personally very happy to see you again. I'm very glad that you're here speaking to us at the Virtual Druid Summit. I'm going to hand over to you.
Yeah, thank you, Peter. Thank you for having me, and thanks everybody for joining. And it's great, as you are saying, to be able to share the work that we have been doing at GameAnalytics for over 2 years already with Apache Druid. And yeah, without further ado, I will start with an introduction to an agenda of what we are going to be talking or covering today. And I will start by introducing GameAnalytics to everyone and giving a very high-level overview of our backend and explaining where Druid fits into the puzzle. And then after that is done, I will go through several lessons learned, so to say, that I hope it will be useful for the community. And then we'll have some time for questions. So regarding GameAnalytics, what do we do? What is our service like? So we provide a user behavior analytics service for video game developers. Mostly mobile games are the type of games that we cover. And we are similar to services like Google Analytics, Google Firebase, Amplitude, Facebook Analytics. And in contrast to those services, we are just focused mostly on gaming. And we provide SDKs for integration that cover pretty much all the popular gaming engines. So we have SDKs for Android, iOS, of course, Unreal, Unity SDK. Yeah, we have 18 of those, I believe, or 19. And also, for integration, we provide a documented REST API that developers can use to integrate. So it's potentially possible to integrate from any code or game or application. And the main tool that we provide for developers is our web application, web service, where they can see all their stats in real time and also historical aggregates for years back in time. Yeah. So the next thing I want to cover is explain the amount of data that we process. And at the moment, our peak is 150 million daily active users. That will be during the weekends. During the weekdays, it's slightly less, around 100, 110 million. And when it comes to monthly, that's around 1.5 billion monthly active users. The SDK, the GameAnalytics SDK, is present in 25,000 games that send data to our service every day. And the number of events is around 19 billion. And all the data is in JSON format. And compressed every day is in S3 is around 1 terabyte. So I'm talking about 25 daily active games, and our main user will be an indie developer, which will have one game, or a studio that has even up to 1,000 games, or our biggest one. And we provide an overview where they can see all their games across the platform, compare stats, and see which ones are performing well or not performing well, and spot potential winners in prototypes and things like that. Yeah, approximately yeah, we could have something like 90,000 game developers that have used the platform since the beginning of time, almost 8 years ago. And this view is our main dashboard view, where users can track any KPI, which is a key performance indicator, things like new users, DAO, and yeah, we provide an overview that can be custom and so on. So I mentioned the word key performance indicator, and this is when it comes to gaming, the most important one will be player retention. And player retention relates to the amount of players that keep coming back to the game after X days. So, for example, we have an example here where the day one retention is 30%, day two retention will be 19%, and so on and so forth. And this is a very typical graph, like where the difference in retention per day is around these numbers. And small variations in this performance make the difference between a game that is going to produce a good revenue and a game that is not going to produce a good revenue. So these are the type of KPIs we track. Another KPI could be LTV, long time value, or the number of daily active users, for example. So this is what our users are interested in tracking from the games. And this is just a general KPI, right? But what we want to provide and what we provide is complex filtering and complex visualizations based on different dimensions. And you know, we allow the users to display KPIs split by countries, by you know, they can filter in different ways, and we want these filters to be very responsive and very quick, and that's where Druid comes into play, as we will see later on. And yeah, the filters that we allow to use are really like provide a really lot of detail into what's happening in the game. So the studios can create their own instrumentation and then use our tool to filter, and the filtering has to be very quick, very fast. We don't want the users to be waiting for seconds for a page to load or a graph to load. So having explained a little bit about GameAnalytics, I want to go through an overview of what will be the technical requirements for such a system, right? So the first thing is that, as I said, you want a low query latencies because you want a responsive front end, and that's something that, you know, you cannot have queries taking several seconds because the loading time will not be translated to a good experience for the user. We need a streaming ingestion because we want real time. We allow the users to track what's happening in the game in real time. Of course, reliability, that should be a requirement for any technical system or any technical solution. And then keeping infrastructure costs low is very important, considering that with this amount of data is not an easy thing to achieve. And then the flexibility in the querying and in the filtering, so that the users can really dig into the data and get value out of it. And another thing is that most of the queries and the metrics we track are related to the number of unique users. So, you know, for example, the daily active users, number of users, ARPDAU, which would be average revenue per daily active user, also related to the number of users or unique users in the game. And then having these requirements, how does an analytics service look like under the hood, right? The three main components will be, from a very high level point of view, the three main components will be a data collection component and data annotation and enrichment component, and then finally the aggregation and reporting service that provides the values. Explaining a little bit about data collection, we run a web service with an auto-scaling group, and it takes the events and provides them to S3. And we use a language called Erlang to keep the costs low because the traffic is really massive. So we want the reliability and low cost. And those are the SDKs that we support mostly. Then the second system is the data annotation system that prepares the data for ingesting into later on Druid, and that's what we call denormalization, because in Druid, as we know, data has to be prepared before ingestion usually. This is quite a regular pattern. And the Redis and Dynamo at the bottom represent the state. So we have raw data bucket in S3, then we annotate the data and write it again into S3 in the annotated bucket. And we annotate that data with a state that is stored in Dynamo and Redis. So the question is, where does Druid fit into this picture? And this will be the last bit of the system, which is the annotation, the reporting and aggregation. And we see the annotated data bucket that from the previous slide. And that the data goes into Druid in two ways. It goes through batch ingestion with EMR and Hadoop, obviously. And then the other way we ingest it is by having a real-time kinesis stream that we create with lambdas. And the reason why we have the batch ingestion is because we re-ingest the data later on to roll up and so on. And sometimes we ingest data without ingesting it in real time. So we need both. And the last component that is important in this slide will be our query layer, which is built in-house and allows us to abstract complexity from the front end. And we will talk more about it later. And that query layer is what our front end communicates with and queries. So as I said, we use EMR for ingestion, and we use AWS step functions to coordinate this ingestion. And we are slowly moving to native ingestion because the latest release of Druid it supports perfect rollup and will probably allow us to save money. And we are working on this at the moment. Regarding the query layer that I mentioned before, we decided to build our own query layer, and this, as I said, provides abstraction for front-end, makes their life easier. And also we implement our authentication that works well with our authentication system, and we can fine-tune things like caching and play with query priorities, rate limiting, and so on. We implemented this using a language called Elixir, which is a language that targets the same virtual machine as Erlang does. And we use this language a lot within the company, and we created our own Druid client for Elixir because there was not there wasn't one for this language. And it works with macros and generates queries in JSON native format for Druid. And it's open source. You can find it in the following link. So about Pivot, we also use Imply Pivot, and we use it internally as a BI tool so that our employees can track any detail they want in the data across all games, across all our studios. And yeah, that's very useful for us. I wanted to talk a little bit about A/B testing because it's the latest feature that we have released within GameAnalytics. And what is A/B testing, right? It's well, Druid is very important for this A/B testing feature. It's the main component of the feature. So an A/B test for GameAnalytics, a game analytics service, consists on basically splitting your users within the game or some of your users into different groups and observing the results for a particular metric or KPI for those different groups. And after doing that, you can analyze the results and apply probabilistic models and seeing if the differences that you observe are statistically significant or they are not statistically significant. And this is an overview of how the feature looks like. We provide a table of results. We provide probabilistic analysis. And then there is a menu where the users, the studios, the game developers can define criteria to include players. They can define the different variants and control group and the target metric that they want to analyze probabilistically. And the way this works with Druid is simplifying quite a lot. Is basically what we do is we have an A/B testing service where the mobile device will fetch the variant that is assigned to it. And then through our regular data collection service that I described before, we just simply annotate the events and then they end up into Druid. And by doing that, we can use all the Druid features to, in real time, see how many users the experiment is acquiring. We can already show in real time the partial results to the users so that they see what the experiment is going. And then we know when the experiment and the data is ready to run our probabilistic model to provide the results. And yeah, these variants are just 3 dimensions, so we can also allow them to filter using the filter that I described before, like any other parameter they can use in that filter across the tool. Having explained a little bit of the overview of Druid and our backend, I wanted to also describe the cluster topology that we have, and we use Imply Cloud to manage and deploy our clusters. And we have obviously 3 types of servers: the data servers, which run with their managers and historicals, We have a query, which they run the brokers, and master nodes who run the overload coordinator and zookeeper. And as you can see in this slide, we use for the data nodes historicals i3 8x largest, which are instance types with big SSDs or relatively cheap SSDs as well. And we have at the moment 15 of them. And we have a second tier. I will talk a little bit about it later. And the brokers are simple enforced, so not very big machines at all. And these setups works really well for us. What else? When it comes to performance, one important thing to mention is that we use multi-tenancy. So all our queries filter on tenant ID dimension first. And so it's always this filter for the front-end interactive queries. And then we have around 75,000 queries per hour going to our Druid cluster. And we have data sources with hourly and daily rollout. And the DAO that we have in our web tool, so the number of the game developers checking metrics in the front-end interface is around 1.5 thousand, so 1,500 users per day. And these are some performance numbers from Implied Clarity, which is the monitoring service that we use. And we have something about around like 200 milliseconds average query time, and 98% is 1.27. And this is during the one day, any day in the week, which is really fast. I think we are very pleased with the performance. And yeah, this is basically an overview of our Druid solution. And I wanted now to go through some more details on the small things that we have learned along the way. And the first thing I wanted to talk about is the partitioning, because as I explained before, we use multi-tenancy. So that means that we always partition based on the tenant ID, which in our case is the game ID. So we always partition by game. There are some queries that go across games, but most of our queries are always filtering on game ID. And then the problem that we have with this is that by doing that, it results in unstable EMR ingestion for us, because we have games that are very big and games that are very, very small. And this changes, right? We can have a game that today is small and suddenly becomes very popular, becomes huge, and then it kind of becomes not as popular again. It becomes smaller. So this is very unpredictable, and we cannot have a criteria for classifying games. So we were not able to make the partitioning work, and then we had to resort to hash partitioning, which still works very well. The performance is good, but could be better with the single dimension partitioning. But maybe in the future we could try to revisit this and make it work, but it's gonna be not easy. Then I also talked about the query layer. I mentioned about the caching, but I just want to mention that this is extremely important to do well. So you want to have the best caching possible in your query layer to reduce the number of queries going to your Druid cluster as much as possible. And this is a regular pattern when querying a DB from a user-facing application, but just something that I think is worth mentioning. And if you use Pivot, of course, Pivot does this for you in a very smart way, so you don't need to worry about it. Going back to the annotation system, which is the normalization process that I mentioned before. I wanted to explain why we have this, mainly for two reasons. One of the reasons is that we get two types of data, which are two data streams, separated streams. One is the data from our devices generated by our SDK. Another data is attribution data, which explains where the users come from. And this comes from in the form of callbacks from our attribution partners, which are companies like Adjust or AppsFlyer. So we want to get those two streams of data, which arrive in real time, and we want to join the data so that then we can filter in Druid. We can filter users from which ad campaign brought this user to my game, and this is very valuable for our end users. And the way we do this is with this annotation system, so that then in Druid is just a simple filter. And another thing we do is use this for this annotation system to calculate player retention. And one way in Druid that you could calculate retention will be using the theta sketches. It's described the way you could do this in the Druid documentation. The problem with this is that the sketches are expensive for us. So we did some tests and increased the size by 30%, and of course cost. And I think that we didn't test it with a production level load, but I think it will put quite some strength into the work progress, I believe. So what we do is use this annotation system to use the state of the player to annotate the installation timestamp for every event. And then for Druid, to calculate rotation is a simple filter, which makes it easy and very fast. I wanted to discuss something related to the schema design, the structure of the data into the data sources, because as I explained, we have the two streams that we join. So finally, we have one annotated stream of data, and all our data resides in that one single kinesis stream, or also in the S3 bucket. So the same data is in both places. So the easiest thing to do will be to ingest all our data in one single data source in Druid. And that needs one ingestion, real-time ingestion, and maybe some compaction, and then everything works. You can query anything you want, and it works. But the problem we have here is that we have, obviously, like I guess any Druid users, we have high cardinality dimensions and low cardinality dimensions. And a lot of our queries only will filter in low cardinality dimensions. A low cardinality dimension could be something like country, while if you don't use the filters into the high cardinality dimensions, then kind of you are scanning maybe too many rows because the resulting data source has a lot of rows, right? So you want to reduce the number of rows processed to speed up your queries. So what we have is 3 data sources at the moment. So we have this single data source where our data is present, which we call here like the full data source. And we have something about something like 2.5 billion rows per day. I mentioned before that we have something like close to 20 billion events per day. And then we have 2 data sources that are like subsets of this big data source, right? We have a reduced one and a small one, and those are way smaller than the big data source. So all these numbers are for daily granularity rollup. And as you can imagine, if we have a query that filters in a dimension that can be served by the small data source, it's going to be many times faster than running it in the full data source. So we have this set up, and the speed of the queries is much better than if we were to have only one data source. This, of course, has advantages and disadvantages, like any technical decision that you might make when designing a Druid schema. And the advantage is dramatic increase of query performance, of course, as I mentioned. And then you can also apply different retention policy per data source. So data that has a lot of detail in the main data source, we can drop it earlier than the more aggregated data in the smaller ones. And also you can have different metrics per data source. You can have, for example, little test sketches that are expensive only on the small, or things like that. And the disadvantage, of course, is that it increases the ingestion complexity and the cost, because you need one ingestion per data source. And then increases the complexity on your query layer, because you need to be able to select the optimal data source. And then, of course, it increases the storage use, because you are storing the same data several times, potentially. So then you also have a lot of multiple ingestions that you can take when it comes to the ingestion approach. And one simple approach could be, because we query all our data in real time, right? Or most, so one approach could be that you have 3 real-time ingestions generating the 3 data sources, and then you just run compaction for each of them, and then you end up with all optimal segments, and you can query everything in real time. And this is simple, but of course, the cost in the kinesis stream will go up because you read it 3 times, which is another option. Could be that you just ingest once in real time in the full data source, and then you run a compaction to compact that data source into optimal segments. And then from the segments generated in real time, you can use EMR or native ingestion to generate the other data sources. The disadvantage of this is that all the real-time queries, they will need to go to the big data source, so the performance there might not be the best. And there could be other options, but yeah, this is it's always like a trade-off relation to the cost, the queries you're running, and so on. So when it comes to tiering, I mentioned it before that we have 2 tiers of servers, and what we do with the second tier is to serve some data that is older and that is accessed not very often, so that we can save money. And we run this in a new instance type that Amazon, I think, launched around a year ago, that is called i3EN, which has for approximately the same cost, for approximately the same cost, it has bigger SSDs. And another use case could be, for example, to use tiering to run the most queried data or the most accessed data with more powerful hardware or with more replicas. We don't do this, but is another possibility to speed up your queries. And finally, I wanted to talk a little bit about lookups and joins, because joins is a new feature in Druid, and we are starting to explore that one. And lookups allows you to join data stored in Druid with data that is not stored in Druid. It could be data in a MySQL DB, for example, which is our case. And what we have is that we ingest the game ID, which is the main dimension that we filter always on. And then we have this relation stored in a MySQL DB. No? We have, for each game ID belongs to a studio, and each studio belongs to an organization. And with the lookups, we can query in pivot and in our query layer by a studio and organization ID. The problem we have here is that we also have the concept of a general, and what happens, a game can belong to multiple genres, and a genre can have many games associated with it. So this is a many-to-many relationship, and this is not supported on lookups. So there is no real way for us to do this at the moment. But there is a feature coming up in Druid as part of the improvements on joins. It's called index tables, that I think will be allowing us to address this problem. And they are similar to lookups, so that they are global tables. And I think that the join can be performed in the historicals, the data node, which is very fast. So we are keen on exploring this new feature. And yeah, that's about it. That's hopefully a useful overview from GameAnalytics about our backend. And yeah, I want to thank also our technical teams for working hard to make this possible. And I'm just lucky to present here, be able to present their work. But yeah, this is performed by one team in GameAnalytics, our backend team, and it's a team of 5 engineers. So thanks.
Thank you very much. You know I'm going to say you're wonderful. I'm always going to say you're wonderful. I love it whenever you speak. So that was really great. And I reckon there were probably 5 other talks that I could try and get you to do just based on that one slide deck, I think. So thank you very much. Thank you very much, Ramon. Okay, so we have a lot of questions. Please keep them coming. Please use the Q&A tab at the bottom of the Zoom panel and keep asking questions. So I'll move on to our first one. You just closed by talking about your team, actually. The first question is, what kind of skills did you end up feeling were essential for building what you've built around Druid?
Well, first, I would say that the background of most of the team members, for all of the team members, is mostly on distributed systems. So we didn't have a real background on big data processing. So that probably is not a requirement if you are willing to learn. Druid is a relatively new approach, a new technology. So we have been able to do it. But I think it's very important to have experience with DevOps and platform, being able to know which is the right service to use for the problem, being able to automate everything, automation, monitor everything very well, alerting. So if you want to have a stable system and sleep at night, everything has to be automated, auto-scaling groups and so on. And then when it comes to problems like learning how to use Druid is something that you can learn, I guess. But if you have never used, work with a production system and knowing how to handle platform, I think that will be very difficult, but that's my opinion.
Yeah, cool. Thank you. Okay. Could you elaborate a little bit more on how you set up and optimized the caching that you've got within your architecture?
Yes, so the caching is implemented using in-memory in Elixir. We use a library for Elixir, which is called Cachex, that uses something, a concept that in the Erlang VM that is called ETS tables, that is basically allows you, it's like a key value store, global key value store in memory within the VM, and we use sticky sessions. So we don't use Redis. And that works very fast. It's really cannot be faster. And I think in Erlang becomes easy because you have this ETS and the concurrency is built into the machine. So any request code that comes in can fetch and update and fetch from the cache. So it's easy to implement with this library and it works really well.
Right. So is that kind of intercepting the query and only getting it to execute in Druid when it needs to execute. Is that the way it works?
Exactly, that's how it works, yeah.
Okay, and that's very similar. We heard at the last Druid Summit as well as a talk from Target where they've implemented a very similar kind of, not in Erlang, but a different mechanism, but similar.
Mm-hmm.
A question about what you did for hash partitioning specifically.
Yes, what we did. So this was back in the day when we tested the ingestion with our data. So we ran many tests. And the problem that we had is, as I'm explaining, that when you do hash partitioning, I believe that all the data for example, one game, because in this case it's game ID, will need to belong to one segment. And then what happens is that we have a massive game, right? Like imagine that we have a game that has like, I don't know, 5 million daily active users or 10 million daily active users with a lot of events. So what happens is that that segment will be massive. And then we have a lot of very tiny games that I believe the partitioning tries to put them together into one segment, but it was just not working with our EMR ingestion because of the differences in the game sizes. But now that we have the new data sources that are smaller, maybe that will work. So we might want to try it out in those small data sources. But the performance is anyway very, very good. So yeah, I think that we will not gain that much.
Whilst you're talking about those 3 data sources of different size, am I right to say that that is just by cutting down the dimensions, i.e. the breadth of the tables, that's
Yes.
what makes them small?
Yeah, so basically we just remove from the biggest one to the medium one, we just remove the 3 dimensions with the highest cardinality, which are dimensions where we allow our users to instrument the game. So that's why the cardinality is pretty high. And then the smaller one, we just keep the dimensions with the smallest cardinality, like things like country or maybe like platform, you know, if it is Android and iOS or Nintendo Switch or whatever it is, those sort of dimensions.
Cool, thank you. We've got some questions about the actual cluster, the actual hardware, the infrastructure that you're using. So one of the questions is how you arrived at that size of cluster. How did you determine that that was the right size? And then secondly, what types of instances are you using spot instances, on-demand instances? What kind of instances are you using in AWS?
Yes, so for the cluster, we always run the i3 8x largest because I guess sometimes maybe you might want to run R instances if you have very small segments that you want to send really, really fast. But in our case, i3s were the kind of the good compromise. And then simply it's a matter of making your data sources as small as possible so that they actually solve your problem, right? And then you need as many i3s as necessary to keep all the data inside without overflowing the disks. In our case, in case you have more queries than we do, maybe then you will get to a point when you are CPU bound, but we are disk bound. The CPU kind of copes with the load perfectly. So it depends. If you are CPU bound, maybe you want something else than i3s. That will be about it. Depends if you are CPU bound or disk bound. We are disk bound.
Were you using any particular metrics to observe what the performance was like? Was that an iterative thing, or did you do a lot of that planning up front?
Well, I think that you can do some planning up front, but in our case, once it's in production, you just monitor in production. We use Clarity to monitor Druid in detail, and then of course we have good monitoring on the query layer. So we'll keep an eye on both, and then you just want to make sure that you don't have timeouts and that your query time is good. And we arrived to our query time of 200 milliseconds average, so I think it's very fast. But we were not there from day one, right? For example, the caching, as I explained that as a lesson, that it's important to do it really well, because if you send too much load to Druid, then of course that is expensive and kills the performance. So, yeah.
Cool, thank you. Instead of streaming data, goes this question, do you perform roll-ups or retention for historical data? I think I'm answering the question right. And if so, how do you do the roll-ups and retention? Are you using, do you have a batch ingestion as well?
Yeah, so in the presentation, I talked a lot about compaction. We do not run compaction because the way we do is we have real-time data with hourly granularity, and we keep that data for 48 hours, and then we move to daily. So right now, the real-time ingestion generates segments that are good enough for those 48 hours. And then with the reingestion EMR, we roll them up to daily, and that generates perfect roll-up segments. So then we don't need to run compaction. but that might change, right? We might decide in the future to have real-time data, like hourly data for a week. We are thinking about this to support more functionalities in the tool. But at the moment, we don't do compaction. We do roll-up with EMR and generates perfect roll-up. That's how we do it.
Okay, so you're being very careful about the data that's actually being ingested to not shape, it's the wrong word, but to make sure it's optimized for the segment
Yes.
sizes you want.
Exactly. So we are extremely careful with the EMR ingestion so that it generates segments that are around 500 megabytes, 550, something like that. So all our segments are 550 megabytes after the daily rollup. And our data is always daily. The users care about daily stats in the long term, right? Like daily active users and retention per day. So it's only to the last hours that they want to see real time. Like, for example, we have errors. They can see stack traces in the last hour, how many stack traces you have so that you can react to crashes in the games and stuff like that.
Right.
That's one of the features.
So do they have alerting on that data as well? Is that in the platform?
No, we don't support alerting. We support, you can log into the platform to see the errors. But right now, for example, we have a metrics API where we are planning to support fetching this so that they could implement alerting programmatically using that. But,
cool. Yeah. Good. I could talk to you about this for hours, Ramon, sorry. Could you share some thoughts that you have on how to best query extremely high cardinality dimensions, but particularly when we're talking about long periods of time, months worth of data, billions of rows, where you've got this kind of hourly roll up going on? I think you're saying you've got daily roll up. What are your best practices that you think?
I think that there are things that are really impossible, I guess, right? Everything comes to the number of rows that you are scanning. So there is a point when the query just becomes too slow, right? So you need to find a good compromise. And if one of the techniques could be this ingesting into multiple data sources. So if you have two dimensions that have a lot of cardinality that you usually apply filters together, and two other dimensions that you apply filters together, maybe splitting and not. But really, it's like if you are going to scan a lot of rows, then I guess there is a point when you just need a lot of time for the cluster to go through those rows and like join the sketches or whatever it is. So really, like there is a limit where you cannot have too high cardinality, and the performance will drop, I guess.
But you're using particularly, I think you mentioned theta sketches. I think you're using on some of the dimensions, is that right?
We don't use the theta sketches. We use the hyperlog sketches.
Hyperlog.
Almost all our queries, well, we also have counts and sums, but the sketches are very important. Like everything is about unique users. So hyperlog.
Lovely, cool, thank you. We had a question, I think someone was just checking, you're using imply Druid rather than open source Druid, I think, aren't you? Is that right?
That's correct, yes.
Just making sure I get that one answered. My next question was about the Erlang API that's been written. Could you talk a little bit about the functions that you had to actually implement in that Erlang layer?
So we are talking about the query layer.
Yes, yeah.
Yeah, so that query layer is, it defines the metrics so that for the front end is really simple to query, because, you know, when a retention from the Druid API will be relatively simple, but still you need to define a filter. So we abstract that complexity from the front end, and the front end is just, retention, and which they just to make it simple. But that's one of the things. And then that's other things like authentication, and maybe we could, for example, send some queries to another system that is not Druid if we wanted. It's not that we do that right now, but these things are possible. But yeah, it's an opinionated abstraction for the front end.
Yeah, you're able to abstract the logic a bit easier by having that layer, I guess. Exactly. And that's is that open source?
No, only what we open source is the Elixir client. So it's basically something similar to PyDruid, but for Elixir language. And this was built because now Druid is moving towards having a very good support for SQL. But this was built we started building this 2 years ago. So what it does is uses Elixir macros to generate JSON queries for Druid. And now maybe a good approach could be just using SQL. Maybe that is good. I guess that, but back in the day, maybe not that clear.
Yeah, the support is getting better all the time inside SQL, so which is exciting. Okay, cool. I still have some questions, but I'm afraid we're out of time, so I apologize to everybody. We will follow your questions up in a blog post, I'm sure. Thank you very much, Ramon. Thank you, everybody, for all your questions. A link to the slides and to the recording will be sent out shortly. Please email me and my team at community@imply.io. We've got the latest information about lots of activities across the world for Druid. Don't forget to talk to us about having a 5-minute interview with us, or writing your own blog post, or doing a talk at another meetup somewhere in the world. Would love to invite you to do that. And we can also make sure you get your entry for your organization and your use case on the Apache Druid Powered By page. And I do invite you all, keep an eye on the Imply blog, on ASF Slack, and in the Druid Google user groups. I'm there trying to help, but also we're hoping to have an announcement out very shortly about a new discourse powered Druid community forum. And I look forward to seeing you all there. Our next speaker is from Zeotap. He has a very interesting topic. He's going to be talking about data modeling, non-temporal and nested data inside Druid. So that's going to be very cool. It starts in about 15 minutes at the top of the hour. So I look forward to seeing you all then. Thank you, everybody.